Imagine spending billions of dollars building a massive megastructure that engineers already know will one day definitely require major, expensive repair. It sounds completely absurd on the surface. Yet, every single massive hydro dam built on Earth carries a dangerous, entirely invisible expiration date. Some of these modern structures may last a century, some much longer, but absolutely none of them were originally designed to last forever. And that specific engineering limitation is exactly what makes a small handful of ancient dams across our planet so deeply remarkable. Because while modern civilization heavily relies on reinforced concrete, steel, computer modeling, and satellite surveys, a few ancient dams are still standing. Built nearly 2,000 years ago, these marvels are not only standing, but in some remarkable cases, they are still functioning perfectly. They operate with absolutely no electricity, no heavy modern machinery, no reinforced steel structures, and no advanced digital engineering software design tools. Instead, these enduring monuments achieve their purpose using nothing more than raw stone, flowing water, and pure, brilliant human engineering ingenuity. So how exactly did ancient engineers create structures that have successfully survived entire empires, wars, massive earthquakes, violent floods, and neglect? The definitive answer to this puzzle begins with a profound architectural mystery hidden deep inside the very construction materials they used. But the unique stone material itself is only a small part of the story, because even a perfectly built dam faces a hidden enemy. It is a relentless enemy that eventually and inevitably destroys almost every single artificial reservoir located anywhere on the surface of Earth. And somehow, against all historical odds, ancient engineers actually found a highly effective way to fight back against that devastating natural force. For many generations, we have viewed human history as a straight, ascending line, assuming that technology always progresses directly forward over time. We look at how primitive stone tools eventually became bronze tools, how bronze became iron, and how iron finally transformed into modern steel. And now, in our modern era, we have added advanced computers, satellite arrays, and sophisticated artificial intelligence systems to that evolutionary timeline. The underlying assumption seems completely obvious to us. If we possess more advanced technology, then we must automatically possess superior engineering knowledge. But historical reality is often far more complicated than that, because modern engineering mostly excels at building things bigger, taller, and faster. Ancient engineering, however, often focused intensely on a completely different metric, an absolute dedication to structural durability and unmatched generational longevity. They focused on the rare ability to survive for consecutive centuries, even millennia, with only an absolute minimum amount of human intervention. By contrast, many of our modern structures depend heavily on constant maintenance. Roads require frequent resurfacing, and bridges require endless safety inspections. Our concrete constantly requires expensive repairs, steel continuously corrodes, protective coatings inevitably fail, and essential industrial components quickly wear out. Ancient builders faced these exact same destructive forces of nature, but they frequently approached them from an entirely different tactical perspective. Instead of designing complex structures that would constantly need to be repaired repeatedly, they frequently sought designs that could cooperate with nature. To truly understand how effective that cooperative architectural approach could be, we need to travel directly to the rugged landscapes of western Spain. There, a massive, serene reservoir still sits peacefully behind a functioning dam that was first constructed during the height of the Roman Empire. And what makes this monumental structure so extraordinary is not simply its immense age. It is the undeniable fact that it still works. On the sweeping plains of Extremadura stands the historic Proserpina Dam, which was originally built during the 1st century of the Common Era. It was designed to supply water to the thriving Roman city of Emerita Augusta, and today, nearly 2,000 years later, the reservoir remains. The structure has certainly undergone maintenance and minor modifications over the centuries, but its original, core Roman masonry still fully survives. At first glance, this level of permanence seems completely impossible. After all, flowing water is an incredibly relentless, destructive physical force. Given enough time, water easily breaks entire mountains apart, carves deep canyons through solid rock, and infiltrates the smallest, microscopic physical cracks. It slowly but surely destroys even the strongest man-made materials on Earth. So why exactly didn't it destroy this ancient Roman dam? The fascinating answer to that question lies deep inside the unique material chemistry of ancient Roman infrastructure and concrete construction. Roman engineers masterfully used a remarkable building mixture containing a unique volcanic ash known as pozzolana, which they combined with raw lime. When continuously exposed to water, this ancient material behaved completely differently from many types of concrete used in our modern world today. Modern researchers studying these ancient Roman structures have discovered clear evidence that certain mineral reactions within the material help strengthen it over time. In some remarkable cases, tiny, interlocking crystals actually form within microscopic fractures, effectively helping to limit any further structural splitting or damage. In other words, for these ancient Roman builders, the water was not always viewed as an aggressive, destructive enemy to fight against. Under the right physical conditions, the moisture could actually become an active, helpful part of the long-term structural engineering solution. But even if the material remained durable, another severe environmental threat should have completely destroyed the reservoir many centuries ago. It is a dangerous threat that actively affects virtually every single hydro dam that has ever been constructed throughout human history. And unlike structural cracks or external weathering, this hidden enemy rises silently and invisibly from the very bottom of the water. The greatest long-term threat to the survival of many reservoirs is not actually structural failure. It is the accumulation of heavy sediment. Every single river on Earth naturally carries enormous amounts of shifting mud, fine sand, heavy gravel, and organic environmental debris downstream. When a river's natural path is blocked by a dam wall, much of that loose material settles directly to the bottom. Year after year, decade after decade, century after century, the reservoir silently and continuously begins filling itself with thick earth. Gradually, the water disappears, the storage capacity shrinks dramatically, and the dam slowly but surely loses its original operational purpose. Modern reservoirs often require incredibly expensive management strategies, including heavy mechanical dredging, to combat this natural, relentless sedimentation process. Yet, remarkably, some ancient engineers appeared to understand this complex hydraulic challenge surprisingly well, thousands of years before modern computers existed. In several ancient water systems, builders carefully incorporated low-level outlets and specialized sluice mechanisms designed to flush sediment-laden water safely. Using nothing more than basic gravity and natural water pressure, these passive systems could drastically reduce dangerous sediment accumulation over time. This brilliant design extended the useful life of the reservoirs, operating with absolutely no engines, no mechanical pumps, and no modern electricity. It was just carefully calculated hydraulic design, and this reality raises a highly uncomfortable question about our accepted historical timeline. How were engineers working 2,000 years ago able to understand complex fluid mechanics and water behavior so deeply and accurately? The answer becomes even more impressive when we travel thousands of miles east to a structure that holds a truly legendary status. We find a monument that may be the oldest, continuously functioning water regulation system operating anywhere on the surface of the Earth. In the southern Indian state of Tamil Nadu lies one of humanity's absolute greatest, yet criminally underrated, historical engineering achievements. This is the Kallanai Dam, a monument also known across the world as the Grand Anicut, which was constructed over 2 millennia ago. Built during the ancient reign of King Kallanai of the Chola Dynasty, it continues to heavily influence regional water distribution today. Most people today imagine a dam as a giant, solid wall standing in brute defiance against the flow of a river. The brilliant builders of the Kallanai Dam approached this massive hydraulic problem from an entirely different, highly sophisticated engineering perspective. Instead of trying to completely stop the powerful Kaveri River, they chose to work directly and harmoniously with its natural momentum. Massive, unhewn stone blocks were carefully placed across the active riverbed in a highly strategic and thoroughly planned geometric formation. Rather than creating a massive, stagnant reservoir, The structure was engineered to redirect water precisely into a network of irrigation channels. Simultaneously, the open design allowed excess river flow to continue moving safely downstream, preventing dangerous pressure buildup against the stones. This functional distinction was absolutely critical. The river's immense power was never forcefully resisted. It was merely guided and managed. During heavy seasonal monsoons and floods, water could pass safely over the structure without destroying the deep, mortarless boulder foundations below. And during drier periods, the vital irrigation channels received the exact amount of water needed to successfully support regional agricultural systems. The brilliant design successfully transformed the raging river from a dangerous, destructive obstacle into a cooperative, lifelong partner for the civilization. And perhaps, that is the most important philosophical lesson hidden deep within many of these ancient, enduring engineering projects. The ultimate goal of these early builders was not always to aggressively overpower nature. Sometimes it was to beautifully cooperate with it. Yet the deeper we investigate these prehistoric structures, the more fascinating and mind-bending the story becomes for modern researchers. Because their greatest historical achievement may not actually be the physical technology they used, it may be the mindset behind it. When we look at surviving ancient dams, it is always highly tempting to focus exclusively on their incredible, record-breaking chronological age. But that extreme age is merely the final result. The real story lies in the core principles that allowed them to endure. Ancient engineers completely lacked modern computers, they lacked advanced mechanical machinery, and they lacked satellite mapping or digital fluid simulations. Yet they clearly possessed something equally valuable: generations of deeply accumulated observation, passed down and refined over centuries of time. They intensely studied the patterns of local rivers, they studied seasonal floods, and they studied local stones, soils, and climates. Their structural designs evolved completely around the harsh realities of nature, rather than forcing nature into a rigid, artificial blueprint. Modern researchers and engineers continue actively studying many of these ancient structures today, not because they are merely mysterious, dead relics. Instead, they remain highly valuable case studies in absolute, long-term durability, challenging a common, modern assumption about our technological progress. The more we learn about them, the more they prove that newer does not automatically mean better. Sometimes newer simply means newer. And occasionally, the deeply forgotten past still has incredibly profound lessons to teach our current future, if we are willing to listen. The ancient Roman Empire is completely gone. The legendary Chola Dynasty of India has vanished, and countless kingdoms have fallen into dust. Yet against all odds, a few of their incredible dams remain, still standing tall, still beautifully shaping the surrounding natural landscape. They are still actively influencing the movement of water, thousands of long years after their original human builders completely disappeared from Earth. That undeniable fact forces us to ask a difficult question. 2,000 years from now, what will actually remain of our civilization? Will future generations find the glass towers of our cities? Or will our highways and steel bridges vanish beneath time, weather, and decay? Click the next video on your screen right now to discover another profound, forgotten mystery that is currently hidden in plain sight.